We want to talk about protocol modifications, and we're going to be dealing with an enhanced state transition diagram. The reason we're going to do that is because we need to take account of what happens if one node is the owner, but the directory thinks the other node is an owner. So here the meaning of the owner is going to be ambiguous. What's an owner, by the way? Well, the owner is the node that the directory thinks has the right to modify the block. And there's only an owner if the block is in state EM, because if it's in state S, then nobody has a right to modify it. They all have it in read-only mode. Okay, so what do we do to deal with the fact that there might be two nodes that seem to be the owner? Well, we simply split EM into two states, EM sub A and EM sub B. EM sub A means that the directory thinks the current owner is A, and EMB means the directory thinks the current owner is B. Now I want to zoom in on the state transition diagram and see what's going on. First of all, if the block is in state unowned and there's a readx request, well, it depends upon whether there's no sharers or whether there's more than one sharer. If there are no sharers, then what's going to happen is the read is going to induce a change into state EM sub A or EM sub B, but we'll just deal with EM sub A because the diagram is perfectly symmetric. And if there's a read X, well, then the block is going to move into state EM sub A as well. If there are no sharers or if the block is being read with an intent to write, then it moves to state EM, in this case EM sub A. Now if there is greater than or equal to one sharer, and I think the diagram is wrong because it says more than one sharer, if there is one other sharer or more, then the block is going to move into state S. So this is a read request, and there's a reply D, which means that the data is going to be sent by the home node, and the block is going to move into state S. Now let's deal with the case where the block is in state EM. Let's look at EM sub A. If there's either a read or a read X of block A, then the block is simply going to stay in state EM sub A. In fact, the only two ways it can get out, first of all, is if somebody else issues a read X on it. And in that case, if it's node B, well, we just transition to state EM sub B. And if there's a read on it by some other node, now it's shared, so we have to move to state S. Now if the block is in state S and you get a read request, it simply stays in state S. If you get a read X request or an upgrade, in either case, the block moves to state EM sub A. If it's a read X, it does a reply D, so it sends data back. If it's an upgrade request, well, the data doesn't have to go to any other block, so it just sends a reply message. But in either case, it invalidates sharers. And since the diagram is symmetric, those are the only transactions we need to consider. And now for the quiz, I just have several questions that ask what I just told you. The last possibility is that the directory has an out-of-sync view in cache states, and let's assume it's in state EM sub A, and then it receives a request from A. Well, that shouldn't happen because A is supposed to be the owner, but this means that A's block must have been replaced in that cache due to a cache miss. Some miss was serviced, we had to eject this block. Now the directory knows that A is really the owner, so it can just send the data back. It responds with a reply D.